Hi, my name is Alex Yu. I am a professor of data science and artificial intelligence. Today I will discuss disaster recovery and business continuity planning in cloud computing, and therefore now I am standing on the cloud. Understanding the backbone of resilience. Disaster recovery, DR, and business continuity, BC, are two distinct but interconnected concepts that form the backbone of organizational resilience. Business continuity is the overarching strategy focused on ensuring that a business can continue to operate during and after a disaster, addressing a wide range of potential disruptions from natural disasters to cyberattacks. Disaster recovery is a subset of BC. It is the technical plan for restoring IT infrastructure, systems, and data to resume normal operations as quickly as possible. A robust DR plan follows a methodical 5-step process. 1. Risk assessment. Identify potential threats and vulnerabilities that could disrupt IT systems and business operations. 2. Business impact analysis, BIA. Determine the impact of a disruption on critical business functions, including financial losses, reputational damage, and compliance violations. 3. DR planning. Develop a comprehensive plan with clear roles, responsibilities, recovery procedures, and communication protocols. 4. Implementation. Set up backup and replication systems and configure failover mechanisms. 5. Testing and maintenance. Regularly test the plan to ensure its effectiveness and update it to reflect changes in the environment and emerging threats. In the modern threat landscape, BC/DR has become an essential component of a cyber resilience strategy. The rise of ransomware and other sophisticated cyberattacks means that organizations must have a tested plan in place to quickly restore compromised data and systems to minimize downtime and mitigate financial losses. Adding structure. The ISO/IEC 22301 framework. Behind every great continuity plan is a framework that prevents chaos from turning into catastrophe. The ISO/IEC 22301 standard, formerly known as the Business Continuity Management Systems (BCMS) framework, provides a global benchmark for designing, implementing, and improving continuity strategies. It emphasizes proactive risk management, leadership commitment, and continuous improvement. Essentially, it's the seatbelt and airbag combination for your organizational resilience. Following this standard helps ensure that recovery strategies aren't just well-intentioned but also auditable and globally recognized. Cloud-based DR. A paradigm shift. The cloud has fundamentally changed the economics and accessibility of disaster recovery. Historically, a robust DR strategy required a significant capital investment in a secondary, on-premises data center with redundant hardware and networking infrastructure. This was an expensive and often underutilized resource. Cloud-based DR solutions have emerged as a cost-effective alternative. They allow organizations to leverage the scalable and secure infrastructure of a CSP to back up and replicate their data. A key innovation in this area is Disaster Recovery as a Service, DRaaS. Disaster Recovery as a Service is a cloud computing model that provides on-demand standby computing capacity, meaning organizations only pay for recovery resources when they are actually needed. This shifts the financial burden from a fixed capital expense to a flexible operational cost, making sophisticated DR accessible to a broader range of organizations, including small and medium-sized businesses. A major advantage of DRaaS is the ability to conduct non-disruptive, on-demand testing using sandboxes. These virtual environments allow a test copy of the DR-protected application to be deployed and tested without affecting the production system. This feature addresses a common weakness of traditional DR, where plans often go untested due to the cost and complexity of a full-scale drill. Think of it as a fire drill for your digital world, but one where nobody gets stuck on the stairs and you can reset everything with a click. Strategic DR architectures. The selection of a disaster recovery strategy is a strategic business decision that must be aligned with the organization's tolerance for downtime and data loss, typically defined by the Recovery Time Objective, RTO, and Recovery Point Objective, RPO. From the BIA beyond these, organizations now also use Recovery Level Objective, RLO, which defines how deeply systems or services should be recovered, and Service Recovery Priority, SRP, which ranks which systems get rescued first when chaos strikes. It's the digital equivalent of deciding who gets the life jackets first on a sinking ship, mission-critical databases before the office snack ordering app. There are 4 primary architectures, each offering a distinct balance of cost and resilience. Backup and restore. This is the most cost-effective option, involving the backing up of data to a secondary off-site system. It has the longest RTO, as it requires the time and effort to provision new infrastructure and restore data from backups. Pilot Light. This strategy keeps a minimal core infrastructure running in a standby region. When a disaster occurs, this pilot light is quickly scaled up to a full production environment. It offers a medium RTO in cost, as some infrastructure is pre-provisioned, but compute resources still need to be activated. Warm standby. This approach involves maintaining a fully functional, scaled-down duplicate of the production system in a standby mode, with live data continuously replicated from the primary environment. It offers a low RTO and is suitable for business-critical systems that require a fast recovery time, but at a higher cost than Pilot Light. Multi-site active. This strategy involves running a full production system in 2 or more active regions simultaneously, with traffic distributed across both. It is the most expensive option but provides the lowest RTO and near zero downtime, making it ideal for the most critical applications that demand continuous availability. Real-world resilience in action. Companies like Netflix and Capital One are prime examples of how DR is no longer a back-office afterthought but a core competitive advantage. Netflix runs on a multi-region AWS failover architecture, meaning if one region goes down, another seamlessly takes over. They even run a tool called Chaos Monkey, which intentionally breaks parts of their system to ensure everything is truly resilient, a bit like teaching your system to survive zombie apocalypse drills. Capital One, one of the earliest major banks to move fully to the cloud, leverages automation and AI-driven analytics to detect anomalies and trigger failovers automatically. Their DR system acts faster than a human could even type the word incident. Similarly, Airbnb and Spotify use multi-cloud DR strategies, ensuring their systems remain available even if one provider experiences downtime. For them, resilience is not optional, it's survival. Best practices for resilience and preparedness. A disaster recovery plan is not a static document. It is a living process that requires continuous attention and adaptation to remain effective. The success of a plan depends as much on the team as it does on the technology. The human element is the ultimate variable in a crisis, and a well-designed plan can fail without a prepared team. A modern approach to resilience planning should include several important elements. Regular testing. A plan is only as good as its last test. Organizations must regularly test their DR plans through simulations and drills to identify weaknesses and ensure their effectiveness. Employee training. Employees should be trained on their roles and responsibilities during a disaster. Training should be frequent and clear, as unprepared personnel can turn a minor incident into a catastrophic failure. Gamified simulations are an emerging way to improve engagement and knowledge retention. Clear communication channels. A plan must establish clear, timely, and consistent communication channels for all stakeholders, employees, customers, and partners, to minimize confusion and prevent the spread of misinformation during an emergency. Leveraging automation and analytics. Organizations can enhance their resilience by implementing automated failover mechanisms for critical applications and by using AI-driven predictive analytics to anticipate potential disruptions before they occur. This proactive approach allows an organization to take preventive measures rather than simply reacting to an incident. Immutable backups and blockchain-based audit trails. In today's ransomware-heavy world, backups are the crown jewels of recovery. But even crown jewels need a vault. Immutable backups, data copies that cannot be altered or deleted, serve as that vault. They prevent hackers, and sometimes careless employees, from encrypting or destroying the very data meant to save you. Meanwhile, blockchain-based audit trails add a new dimension of transparency and tamper-proof accountability. By recording every transaction or change in an immutable distributed ledger, organizations can prove compliance, trace recovery actions, and even demonstrate to regulators that, yes, we really did back up that database on Tuesday. It's like having an incorruptible black box for your cloud operations. The human factor and continuous adaptation. In conclusion, investment in DR technology is absolutely necessary. However, without an equivalent investment in human readiness and continuous process improvement, the return on that investment will be minimal. The ultimate goal of BC and DR is to ensure that when the inevitable disruption occurs, the organization is prepared to handle it, thereby minimizing the impact on its operations, reputation, and bottom line. But let's not forget, resilience is both art and science. The cloud may give us infinite computing resources, but it's still human imagination and preparation that keeps the lights on when the storm hits. Finally, there are some questions for your reflection. As AI systems begin automating resilience itself, who watches the watchers? Can blockchain and immutable data guarantee trust in a world of deepfakes and digital sabotage? And most importantly, is your organization testing its DR plan, or just trusting that it works? I'd love to hear your thoughts. Have you ever experienced a real-world system failure or disaster recovery test? What lessons did you learn? Drop a comment and share your story, because in the world of resilience, shared experience is the best backup of all. Thank you for watching. Mahalo.